Our next speaker is Dr. Jonathan Thornburg. He is the Senior Director at the Center for Exposure and Health at RTI International. He aids the center's research, focusing on inhalation exposures and the resulting health impacts from the cellular to the population scale. The center has patented 17 technologies to measure inhalation exposures, protect people from those exposures, and deliver therapeutics to treat an individual. Welcome.
Hello, everyone. It's my pleasure to speak with you today about fungal, whoops, there we go. Fungal allergens and the relationship to children's asthma. Click too soon. Tonight I will give a brief overview of one particular fungal allergen in general, and then define the different types of asthma that children express, and then I'll proceed to explain how those two work together to impact a child's asthma status. So fungi, they're everywhere, right? They're inside our homes. There's mushrooms popping up in our yards every spring. You know, we're exposed to fungal allergens every day of our lives, at home, at work, wherever. Now, there's one particular type of a fungal allergen called a 1,3-beta-D glucan, which Dr. Shaw briefly mentioned. It's common in most fungal species because it's part of their cellular walls. And these glucans, for short, are known to cause allergic asthmatic responses in children, especially in children. So asthma types. So there's two clinically defined asthma endotypes. One is type 2 high, which is associated with allergic allergy in children, but that is also easily medically controlled. However, if a child with type 2 high asthma has an asthma attack, it's more likely they will have an exacerbation and will have to go to the ER for medical treatment. The second type is T2 low, which used to be separated out into T17 and T1. And that's associated with non-allergic asthma, and that is much harder to control medically. So how do we link these together? So RTI participated in a research study, Denver-based research study, that was looking at air pollution, including glucans, and its impacts on the asthma status of children. So the purposes of this talk, I want to explain that we had the children wear a wearable personal exposure monitor to breathe the air pollution to measure the air pollution they were breathing. The type of air pollution we were looking at really was everything in the particulate matter of size 10 micrometers or less, and that all that particulate matter, PM10, was collected on a filter, which we could take back to the lab at RTI, extract and quantify the amount of glucans in the PM10. We can then convert that to an average concentration that the children were exposed to while they were wearing the RTI MicroPEM. Each child in the study wore the MicroPEM 3 times, 4 months apart, for 72 hours over the course of a year. Concurrently with the exposure component, Children's Hospital Colorado clinically diagnosed the asthma endotype of each child. So, and what they found was the children fell into 3 distinct groups. On the top, they fell into persistently T2 high asthma endotype. At the bottom, you had 22%. And the persistently low, T2 low asthma endotype. But in the middle, 39% of the kids flip-flop back and forth between T2 high and low asthma endotypes. And that made us all think, why was this happening? Well, Children's Hospital Colorado also collected nasal swabs from each child at each measurement time point. And they were able to and National Jewish Health in Denver was able to run RNA sequencing analysis on those nasal swabs to get the gene expressions data that could be linked to each asthma endotype. So you can see at the top, we have the T1 genes that were expressed. The T7, next is the T17 genes are expressed, so that's all the T2 low. And then T2 high, or T2 epithelial, is everything below that is the T2 high genes. And you can see here on the far left column is how the genes are expressed in relation to their glucan exposure. So the red means that those genes were turned on after exposure to high levels of glucans. And the blue in that same column going up to T17 means that those genes were turned off after exposure to high levels of glucans. So that gives solid evidence that the exposure to high levels of glucans can switch kids from T2 low to T2 high, and conversely, if they were originally T2 high, but they were exposed to lower levels of glucans for a while, they could switch to T2 low. That's my acknowledgements, and I'm happy to take any questions.
Thank you. We've already got a question over here.
Hi, Jonathan. We used to work together, actually, with Pam Jagger. I'm Ashley.
Oh, yeah.
I have a question, though, related to peanut allergy. I'm wondering if that's kind of the mechanism here. So there's always as an earlier presenter mentioned, like peanut-free schools or peanut-free tables because there's risk of allergic reaction through inhalation. I'm wondering what the evidence is there, and is it because it's actually allergic to fungus, or what is the mechanism to have an allergic reaction through inhalation? It seems, is there strong evidence there? I'm really curious about that.
So actually, Dr. Kim and I were talking about that during the happy hour, and I've never investigated inhalation exposures with our MicroPEM, whether there's peanut allergens there. I think the trick is the MicroPEM, the largest size they can measure is 10 micrometers, and that's pretty small. So those allergens would have to be on particles small enough to get sampled. And PNTM is important because that's what actually penetrates into the region of your lungs that causes the inflammation that causes an asthma attack.
Thank you. Any other questions? There's one back there. Sam's coming.
Is mold considered one of these types of allergens?
Yeah, mold and fungi are the same thing.
It's a fungal.
It's a fungal species, yeah, or a type. It's a common term for fungal.
Okay.
Oh, got one over here.
When you were doing the research tests where you would have the kids wear the device, were there certain locations that they would frequent that were seen to be higher mold levels? Because I've heard a lot of like shared buildings and places that are damp and things are known for being higher mold areas.
Yeah. So two-part answer to your question. So first, we collected on a filter, so it was an average level across 3 days of their lives. So we can't measure it in real time. We're working on developing a sensor that can do that. Two, I forgot the second part of my answer, sorry.
Okay, it'll come back to you. It'll come back. There's a question in the back.
Would you expect, like with food allergens, that the early exposure would decrease lifetime incidence of mold reactions? So if you're exposed as a kid, does that decrease your incidence of lifetime reactions?
Oh, to mold, the glucans?
That's right.
Yeah. It should. But again, it's a complex gene environment perspective. If you're genetically predisposed, you're still more at higher risk. And I think what we're showing here is that, at least for these kids, they can flip-flop back and forth between the different types of asthma.
Check. Let my kid into the moldy shower. Hey, okay. Gotcha.
Yeah.
All right, another round of applause. Thank you so much.